In this lesson, we will find slope. So the slope of the line is how steep a line is. How steep a line is. So we always look at that in terms of a ratio, which is of course just a fraction of how many units the line rises or falls, so the change this way, over how many units the line goes left or right, so the change this way. So you can choose any 2 points on a line and use those 2 points to find the slope. So if it's already graphed, we can just count what is the change in y and what is the change in x. A lot of people remember slope as rise over run. This is the slope formula, and we will use that in just a moment when we actually have 2 points on a line and we have to find the slope when it's not graphed out for us. So let's look at a very simple example. What's the slope of this ladder? The slope of the ladder, because we don't have coordinates here, we're just going to think of slope as rise over run. So I'm saying from the bottom of the ladder to the top of the ladder, how much was the rise? 15 feet. How much was the run? 5 feet, which means the slope is 3. That means for every 3 feet the ladder rises, the run is 1 foot. So that gives us an idea of how steep that ladder is going up to the building. Now, there are basically 4 different kinds of slope. There's the positive slope, where the line is slanting upward as you're reading a book from left to right. So from left to right, that would be a positive slope, the gray line. When the slope is 0, that means the line is horizontal. So when I'm finding the slope, that means the 0 is on the top and you have some other value on the bottom. So the 0 on top means the slope is 0, means we've got a horizontal line. When the slope is negative, it points down from left to right. So obviously that's just one negative. So here, this could have been like, say, 2/5 up to over 5. The slope of negative means that I'm moving down, but still to the right. So it slopes downward from left to right, so negative 2/5. The last one, of course, is the undefined slope, and that's the vertical line. And that means that I've got some value being divided by 0. And since we know we can't divide by 0, that would be my undefined slope. So let's take a look. First, let's just look at it in rise over run, and then we'll look at the slope formula using the 2 points they gave me. So if I were just looking at rise over run, I would say, look, I've got 2 points on my graph. If I were to count the rise and the run, I would say, let's say I'm going to use this as my first point and this is my second. So from my first point to my second, I had to go down 2 units. So that's my rise. My rise is -2. My run is 3 units to the right. So my slope is -2/3, which means down 2 over 3, down 2 over 3 to get to the next point on the line. Now, finding the slope using the slope formula would instead use 0, 2, and 3, 0. So I would call this x1 and y1, which is just code for my first x and my first y. And this would be x2, y2, which is my second x and my second y. I'm just going to plug those values in here, which means I'm going to take my second y minus my first y, so 0 minus 2, over my second x minus my first x, so 3 minus 0. And then I'll simplify. 0 minus 2 is -2, 3 minus 0 is 3, and notice that those two are the same solution. Now, most of the time we don't have them graphed for us, so we can't really double check, but we're just going to use our slope formula. So my slope here would be, and again, not a bad idea, if you're first learning how to do this, go ahead and label those points, x1, y1, and x2, y2. So y2 would be 2 minus y1 of -1 over x2 of 7 minus x1 of 1, which would give me 3 over 6, or 1/2. So I often get the question, well, what if I would have called this x2, y2 and this x1, y1? Would I get the same answer? So let's try it just to be safe. y2 would be -1 minus y1, which is 2. x2 would be 1 minus x1 of 7. That would give me negative 1 plus negative 2, or negative 3. And then 1 minus 7, which is negative 6. Negative 3 over negative 6 is a negative divided by a negative, or a positive. 3/6 reduces to 1/2. So you can see it doesn't matter the order that you go in, as long as you, whichever value you start with on the top, you start with the corresponding value on the bottom. Let's try this next one. I've got my slope of negative 5 minus 5 over 6 minus 4, which gives me negative 10 over 2, which gives me negative 5. If you want to leave that negative 5 over 1, you can. As we use slope moving forward, you will want it as a fraction, but for now, negative 5 is perfect. A couple of the special case items will happen here. So again, I'm just going to use my slope formula. 4 minus negative 3 over 2 minus 2. This is a special case because I have 7 over 0. 2 minus 2 is 0. Remember, when the 0 is on the bottom, this would be an undefined slope, which means that if I were to graph it, it would be a vertical line, which makes sense because if I were to graph 2, negative 3 and 2, 4, they would in fact make a vertical line. This is our other special case. 5 minus 5 over 2 minus negative 1 gives me a 0 on the top of my fraction, which means, of course, that my slope is 0. And a 0 slope looks like this. And again, that makes perfect sense because negative 1, 5 would be up here, and 2, 5 would be up here, and that would make a nice horizontal line with a slope of 0. 2 questions for you to try. Press pause, find the slope of each line given the points, and then press play to check your work. For the first, I have 2 minus negative 1 over negative 3 minus 6. That gives me 3 over negative 9. We always reduce. 3 over 9 reduces to 1 over 3. Notice I just have the 1 negative, and so I can leave the negative out front. We typically don't leave it on the denominator, so I would write negative 1/3 like this, or I would write negative 1 over 3. For the second, my slope is 3 minus negative 2 over 9 minus 9, which gives me 5 over 0, which means my slope is undefined. Undefined, which is of course that vertical line. Again, being able to interpret the slope is going to be very important to us. And we always want to know, what does it actually mean? So when we interpret slope, the general rule is that we'll write for every additional x, whatever x is, the whatever y is would increase or decrease by whatever the y value is. So for every additional 1x, unless the denominator is not 1. So let's take a look at this. I've got a bank balance based on the day. So day is x, bank balance is y, because the bank balance depends on the days. This would be the point 7, 500. This would be the point 22, 50. Finding my slope, I would take y2 of 50 minus y1 of 500 over x2, which is 22, minus x1 of 7. That gives me negative 450 over 15, which reduces to negative 30 over 1. So right now I'm going to leave that 1 on the bottom because that's my x. So this is my y, and this is my x. So what that means is for every additional, and then what does x stand for? Day. For every additional day, what does y stand for? Bank balance. So for every additional day, the bank balance, and then what's happening to the bank balance? It's decreasing by 30. So decreases by $30. So that's the interpretation. For every additional 1 day, the bank balance, which is the y value, decreases by $30.